Hi, welcome back. What we're going to talk about now is the way that global energy systems are driving the electricity use that has been vital for human society over the last 100 years, and particularly for development, and how that global power use is driving the increases in greenhouse gas emissions into the atmosphere. And this production of carbon dioxide from using fossil fuels to drive our electricity systems is critical for development, but it also underpins climate change. And so if we're going to respond or address climate change, we have to look at how different energy systems, but before we look at new energy systems, let's look at our existing energy systems. And in particular, the role that energy has and electricity has in underpinning our society. And maybe the best example of that is when we look from space at a satellite image and we can see the lights of population centres at night. Now, this satellite image is a composite of lots of different satellite images because obviously the planet isn't in night simultaneously all around the globe. But this slide from NASA shows where we can see the population centres and the impact of electricity use producing light is dramatic. We now have more than 7 billion people, 7,000 million people, and increasing rapidly all around the world. But one of the other things that's dramatically grown over the last 20 years has been the use of the internet and computers and mobile phones, and the energy required for driving our modern society, driving computers, driving mobile phones, driving the internet is enormous and growing much, much faster than population. So if we're to power our modern society, energy use will grow. But if we're to avoid climate change, we have to find alternative low carbon energy sources. And so if we look at how this energy has been produced from different energy sources over the last 40 years or so, we can see that the largest sources up here have been from fossil fuels, from coal, oil, and natural gas. There's a small amount of nuclear and a small amount of renewable sources and hydroelectricity. But in practice, the dominant energy source, these ones up here, are associated with fossil fuel use. And each one of those, when it's used, is driving more carbon dioxide into the atmosphere. So it's not surprising that carbon dioxide emissions have grown rapidly in the atmosphere as energy use and that energy being produced from burning fossil fuels. So what we're going to do now is look at some of these across different countries. And this slide doesn't show the energy and CO2 production per country. It shows it as an emission per person. And the scale across the bottom shows that the highest emissions are unfortunately in Australia, in the United States, and in Canada. And there are lots of different reasons for that, but in Australia the main reasons are that we have had ample coal and very, very cheap electricity, and that means that Australian emissions of fossil fuels from electricity use are the highest per person of any country in the world. And there are many countries in Africa which have dramatically lower emissions, as well as in China and Asia. The average emissions in developing countries are much, much smaller than in developed countries like the United States, or even when we compare the emissions from European countries, they're much less than in the United States. And so what we will look at is how those emissions in different countries compare across the different energy sources. And now we can look at the emissions associated with sort of different levels of development. And when we look at emissions associated with fossil fuel use in developed countries like Australia or the United States or Europe, almost all of the greenhouse gas emissions are coming from burning of fossil fuels, and there's a very small amount from land clearing. In fact, That's not shown. Oh, no, it's not shown in the developed countries because there's no land clearing, not major land clearing in developed countries already. If we compare that with countries that are developing, we see that the amount of CO2 emissions from burning fossil fuels has reduced by a factor of 2, but the overall CO2 emission as a fraction, the sources are now much greater from land use change, from clearing forests. So this is the relative fraction, or the contributions from different energy sources, of the overall emissions of carbon dioxide and other long-lived greenhouse gases. And then if we come down to the least developed countries, we see that land clearing is now the dominant factor. And even emissions from fossil fuel use are very small. And it's in these countries that are really on subsistence economies, whereas you can see that emissions from fossil fuels are key to the development and the energy profile in developed countries. Let's now look at the sources of energy in Australia for electrical power. And we see that black coal and brown coal here are the major sources, but there's actually relatively little electricity generation from renewable sectors. About 12% of the electricity production is currently drawn from renewable sectors. Australia has a target of having 20% of its electricity from renewable sources by 2020, but at the present we're a long way from that, with only about 12%. And predominantly our electricity in Australia is produced by burning fossil fuels. We can contrast that with a different country, France, similarly developed, some would argue better developed than Australia, but its dominant energy source is from nuclear power. 78% of its energy is drawn from nuclear power, and therefore it has a dramatically lower emission profile in terms of carbon dioxide. It still has some electricity produced by fossil fuels, but relatively little. Some from coal and some from natural gas, but relatively little. And so it has much, much lower per capita emissions of carbon dioxide and a much, much smaller climate change footprint. We can also look at energy sources in India. And again, in India, coal is the dominant source. Nuclear power is also important, as is hydroelectric sources, but there's an interesting comparison that we can look at. We can look at the total energy use in a country like India and a country like Australia, and then work out the per person energy use. And the per person energy use in India, shown up here, is about 165 watts per person. Watts being the power usage. Whereas down here, the electricity use in Australia is around 2,500 watts per person. In other words, the electricity use per person in Australia is about 15 times what it is in India. And that's part of our, if you like, industrial development. But the worst part is that India has a rapidly developing economy with rapidly growing energy use, who aspire to the lifestyles of the typical American or Australian, and therefore, unless there's rapid conversion both in Australia and in India to low carbon energy sources, as energy use grows, without those changes, we are doomed to that worst case, business as usual climate change scenario. Now, of course, energy use depends upon the equipment that you're using. And we can look at the energy use across different pieces of equipment, like in a mobile phone, like in a car, like in an average house. And the energy use in a mobile phone isn't much. It's much, much greater in transportation, like cars, or even in homes. Heating in homes, electricity use, air conditioning, heating in winter, they're all major users of energy, either from electricity or from fossil fuels like natural gas. There is also massive energy use and massive carbon dioxide emissions from things like aeroplanes and international transportation. There's also industrial activity like aluminium smelters. And aluminium is, one way of describing it is like solid electricity because of the enormous amounts of electricity that are used in producing a kilogram of aluminium. But one of the things that we don't hear about so much is how much energy consumption, how much power is used in the global internet. And if it grows as is planned, then the internet will be using an enormous amount of power. 1 terawatt of electricity is expected to be needed to power the internet globally in the future. So what about when we look at the relative carbon dioxide emissions from different sorts of cars? And there can be major differences in greenhouse gas emissions depending upon the energy source, the fuel source, and we're going to look at that in terms of electricity sources in the next lecture. But let's look now at different sorts of cars. And the larger the car, the heavier its mass, the greater will be its emissions, even if it's driven by a normal petrol engine. If it's driven by a diesel engine and it's a smaller car, you can have much smaller emissions. And if you use the car like the one that I drive, which is a hybrid electric and petrol car, then it has much, much lower emissions. The lowest emissions overall would be an electric vehicle. But unfortunately in Australia, electric vehicles cannot be charged from renewable energy sources off the regular grid because so much of the Australian grid is driven by electricity from fossil fuels. So unfortunately, that ends up that an electric car in Australia has worse emissions than even the smallest hybrid petrol combination. But it is possible with an electric vehicle driven by renewable electricity generation off the grid that you can get dramatically lower emissions. And that's obviously the target, is to dramatically reduce emissions associated with all forms of transport. And that can be done with electric vehicles, electric trains, electric cars, electric trucks. And using that electricity has to be produced from zero carbon energy sources. So the World Bank has said that in order to have environmentally sustainable development, we're going to need to have much greater availability of energy and access to electricity. And that is going to be the best solution to reduce poverty around the world. Unfortunately, there are more than 1 billion people around the world who do not have access to reliable electricity. And increasing the coverage is going to increase energy use. The demand for electricity and demand for increasing energy use is enormous, and it will be one of the key solutions to development and to reducing poverty. But if we're to avoid the climate consequences of that development, we need to ensure that there's low carbon and zero carbon energy sources. We can't separate development and increasing energy use from the impacts on climate. So, to summarize, if we're to have sustainability and resilience, it's not just an issue of climate change, it's also an issue of energy use, reduction in poverty, providing adequate food and adequate water to the global populations. And there are billions of people with inadequate access to food, with inadequate access to water, and also with inadequate access to electricity. That can only be solved with increases in energy use. And the inescapable consequences of that will be climate change unless that energy is provided by low or zero carbon energy sources.